Hi, my name is Will Sieber, and I'm a mechanical engineer here at Mid-Atlantic Infrared. And today I'm going to be telling you all about our data center thermal management solutions.
Our highly unique service can help you optimize cooling in your facility, our goal being to reduce operating costs, increase cooling capacity, improve crack redundancy, and enhance equipment reliability at a mere fraction of the price of using CFD or other tools.
Our strategy is simple. We detect airflow and cooling deficiencies using strictly measured and not modeled data. We identify corrective measures that help eliminate such deficiencies, and we predict potential savings to help you achieve a maximum return on investment.
What sets our service apart from others is the way in which we collect, process, and present data. By coupling panoramic infrared images with air velocity, temperature, and humidity readings from our patent-pending data center airflow measurement and mapping tool, we quickly and easily identify undesirable airflow patterns that are actually occurring in the data center. We display results graphically using computer-aided design software, and we also generate cooling quality metrics from both DAM tool and infrared measurements.
The key feature of the Data Center Airflow Measurement and Mapping tool is its special sensors which measure both air velocity and direction accurately at very low air speeds. The tool allows us to create our multi-dimensional vector field graphics which detail airflow characteristics. Our custom designed program performs analysis on rack inlet air property data to calculate metrics such as rack supply and heat indexes and even rack power dissipation. The DAM tool is pushed through a data center with readings taken at each tile. Each reading takes only seconds, so comprehensive studies of the largest data centers can be conducted quickly. We use high-resolution panoramic infrared images to supplement data from the DAM tool. We can determine precisely where airflow and cooling deficiencies exist. Further, we quantify the severity of such deficiencies. For example, this plot here shows percentages of average rack inlet temperatures that are above or below the ASHRAE standard recommended range for each row in the data center. To fully understand the airflow distribution in your facility, we take volumetric airflow rate readings at every perforated tile. We typically see that areas with high amounts of hot air recirculation are largely undersupplied by the perforated tile airflow. Another metric we provide will tell you what percentage of air under-provisioning or over-provisioning is occurring at each rack. This metric is a great indicator of the effectiveness of your crack unit layout. Here is a three-dimensional plot of airflow through all perforated tiles in a data center experiencing under-provisioning. Rows in the middle of the room had high amounts of hot air recirculation at rack inlets because of the low perforated tile flow rates. This data center had too few crack units cooling these areas. We also measure flow rates through the crack units. We determine your leakage rate and show you how much crack unit air is short-cycled and essentially wasted. We conduct a crack unit performance evaluation highlighting power consumption, heat transfer data, coefficient of performance, and more to help identify units that are not operating to their potential. We provide extensive analysis of server power consumption and heat dissipation. We use this information to assess how well the localized and global cooling capacity and airflow meet the needs of your IT loads. We recommend best practice corrective measures, the low-hanging fruit of energy efficiency gains. We engineer specialized perforated tile and crack unit layouts to help you optimize the supply and return paths of cooling air. Ultimately, we help you achieve an equipment layout that will allow safely raised temperature set points in the data center. This is the key step to enhancing your efficiency or driving down your power usage effectiveness number, PUE. This plot was generated from compressor manufacturer data and depicts the energy cost reduction associated with raising crack unit return air temperature set points. A 22% cut in compressor running costs may be achieved by stepping up set points from 68 degrees Fahrenheit to 82 degrees Fahrenheit. By optimizing airflow in the data center, we simultaneously enhance equipment reliability and allow you to gradually and safely raise set points. The resulting decreased compressor utilization alone can reduce legacy data center operating costs by upwards of 20%, increase available cooling capacity for expanding data centers, and improve crack redundancy. Our data center cooling optimization service will allow you to save energy, to save money, and to do your part in creating a greener future. For more information, visit us at midatlanticinfrared.com. Call us today to discuss how we can boost the performance of your facility.